Well, welcome back. We're now going to go over fundamentals of logic. So this is a different way of how you can be doing some PLC programming, and maybe this might be intuitive for some. We'll see how that goes, and you can be thinking about it. So let's first of all think about the binary concept in which this is based. Binary refers to the idea that many things can be thought of as an existing in only two states. So the binary states are 1 and 0. So you can think of on or off, open or closed, true or false, high or low. And so these are the ways that how that can be looked at. And so first you can be thinking of, well, what if you wanted to put on the high beams for your car? So there's two things that actually have to take place. So the light switch for your normal lights, and then there's an additional switch that would have to be switched before you get the high beams out. So that's how you would see as giving an example of an and type of logic. And we'll get into that in a minute. But what about the dome light in a car? It's trying to represent an or. So either the passenger door or the actual switch itself are the things that can turn on the dome light. And so maybe you hadn't thought about it, but you actually have some familiarity with the and the or. And so now let's talk about in a little bit more details how these different types of functions work. So the AND function is a device with two or more inputs and one output. So we're going to just talk about two, but you could have multiple, and then it would just be the similar thing. And since there's only one scenario where you get a output with one, and that's if both of the inputs are one, just like you had in the situation with a high beam. So if I just wanted to split it out in more details, this is what it would look like for the four different scenarios that are shown in this truth table. And so is only when both of them are true or one are you going to get an output of one. And that's what we're trying to show in that case. The AND logic gate operates similar to control devices connected in series. So you need to have two switches in a row for the light to go on in this case. And so you can be thinking about that. And so if you wanted to put in a logic representation, this is how it would look. If you wanted to just have a circuit, this is what it would look like in that case. Well, let's spend a little bit of time looking in more detail for the OR function. And so the OR function is as long as one or both of the inputs is one and the output is one. So that's what that would look like. And so here we're seeing three of the four cases would make this output one or true. And so that's what we see as the case for this type of a scenario. So the OR function, if you look at this kind of a schematic, you can actually have two switches in parallel. So either one of these would actually cause the light to turn on. So this is like the dome light in your car. You have two switches that can actually close a circuit, is what we're trying to show. Then there's also this third type, this something called a NOT function, which basically it's an inverter. Whatever the input is, it's the opposite of the output. So if it's 0 in the input, it's 1 in the output. And if it's 1 in the input, it's 0 in the output. That's how that would work. So the circle indicates an inversion, and we're going to be seeing this as we get into some more complicated type of gates that are also available that you can want to make sure that you're aware of that. So the NOT function can be performed on a contact input simply by using a normally closed instead of a normally open contact. And so that would be one way that you can be thinking about using that kind of a logic, if you will. So the NOT function is used in conjunction with an AND gate on a low pressure circuit indication. So here, if you wanted to just modify it, so instead of just having ones on the input, you could have a 1 and a 0 would produce a 1 on the output. So thus we can start to get a little bit more sophisticated in terms of the kind of programming. Then we have these other specialty kind of gates, and if you're not familiar with these, you can really develop this stuff without this, but this is like a shorthand for having an and then you have an inverter at the end is what it's showing. So the only case when you don't have a 1 in the output is when both of them are 1 in the input. Similarly, for a NOR, it's an OR gate with an inverter on the output, and thus the only case The only time when you get a 1 out is when both of them are 0. So thus we can see of a couple of different ways that can be helpful for us to get a little bit more sophisticated in our programming. And finally, there's the exclusive OR. And so what this is trying to convey is only when one of the inputs is 1, will you get a 1 at the output. So if they're both 1 or both 0, then you'll get a 0 at the output. And so though that's a nice complement of the various types of gates that we'll be encountering. So